myself Bharadwaj. In this video, I will discuss about disadvantages of Foundation Fieldbus. See, the Foundation Fieldbus is a powerful digital communication and it provides lot of features, but there are some limitations. Let's see. The first one is higher engineering complexity. See, when you compare with traditional 4 to 20 milliamp systems, the design or engineering complexity is very high in foundation field bus. You have to consider a lot of parameters like segment power rating, total number of devices, and devices current consumption, cable lengths, terminator placements, etc. Lot of things. If there is some problem during the design time, then you will face lot of problems after the commissioning. You may get instability in the communication. You may get data loss, intermittent communication loss. Lot of problems will come if there is some problem during the design. That is why the design itself is complex when you compare with 4 to 20 milliamp systems. The next one is complex network design rules. The fieldbus segments must follow strict physical layer rules such as the maximum segment length, limited spur lengths, selection of number of devices on the network, proper termination, and correct shield grounding practices we have to follow. If there is some problem during these implementation of these things, then we may experience bad network communication. Sometimes you get communication errors, signal distortion, device dropouts. See, this is one of the main factor we face in our industry, device dropouts. Suddenly the device which is connected to the network, it will go out of the network. Then it will take a lot of time and troubleshooting. So this is very, very important. And the third one is requires highly skilled engineers. Troubleshooting and commissioning FF systems require specialized knowledge, right? Engineers must know about the FF function blocks inside the fieldbus instruments, link at to scheduler purpose and working principle and its configuration or functions, macro cycle timing, device configurations, digital communication diagnostics. So this is completely different when you compare with 4 to 20 milliamp systems. The 4 to 20 milliamp system is very easy to troubleshoot when you compare this to foundation field bus. That means the engineers must have the knowledge and must be trained on the foundation field bus. Then only they can handle these things perfectly. Next one is troubleshooting can be difficult. Yes, obviously. In 4 to 20 milliamp systems, it is very easy to troubleshoot. If there is a broken wire, you can easily understand from the current signal reading. If it drops to 0 milliampere, you can easily understand that there is some problem with the cable or some problem with the instrument. Easy to troubleshoot. But in foundation field bus, there are so many parameters may affect like network noise, power supply instability, improper termination, scheduling errors. So diagnosing these issues often requires specialized fieldbus diagnostic tools. We have fieldbus tools available. You can connect the fieldbus devices, diagnostic tools to the network and you can analyze your communication network, noise levels, network healthiness status, etc. Or if you have the advanced diagnostic modules installed on the Fieldbus Power Hub, you can also see this status in your plant resource manager. That is a software in Yokogawa DCS system. Next one is higher initial installation cost. Yes, FF devices are costly. It reduces wiring, but again, these instruments are costly when compared to hard-based 4 to 20 milliamp instruments because FF systems require field bus power supplies, segment protectors, linking devices. Linking device nothing but your field bus modules, field bus interface cards, field bus motherboards, right? Power hub, configuration softwares, license, etc. The total initial investment is high for the foundation fieldbus. Remember that. Next one, the low communication speed. The communication speed of FF devices is 31.25 kbps. So when you compare with other networks like Ethernet IP, Profinet, Modbus, the communication speed is less. That is why when you work with hard communicators with the foundation fieldbus instruments, it takes a lot of time to update all the data because there are so many parameters on the fieldbus network and there are so many parameters related to single fieldbus instrument. So to fetch all the data, it takes some time. Even if you perform the operation from the control room, it takes some time because the speed is less, 31.25 kbps. But for process control application, it is fine. But overall, if you see, it is low speed when compared to other technologies. And single segment failure risk, it is very, very high. Let us say from field bus junction box, we are using only one pair cable, right? Even though there are two pairs inside, one pair only used, second pair is spare. Let us say there is some problem with that single one pair cable, the trunk cable, some damage happened. Then what happens? You will lose all the instruments communication which are connected to the respective junction box. Let us say there are 15 instruments connected to a field bus junction box. Due to some reason, that field bus junction box trunk cable is damaged. Then suddenly you will lose 15 instruments data, 15 instruments communication with the control system. So the risk is always high in the foundation field bus. That is why you do not use this foundation field bus for safety related systems or critical control loops. Mostly we are using this foundation field bus for monitoring applications or simple control loop applications, not for the critical or safety loops. Remember that. This single segment failures can happen at any stage. Let's say due to cost cutting, you're not going to provide the redundancy. You're not using two field bus modules. You're not using two field bus interface cables. Then the risk is very high at every stage where you don't have the backup. Next one, device capability challenges. See, different vendors manufacturers different field bus instruments, and you are using different vendors instruments on the same network. So sometimes there is some integration issues or device description file compatibility problems. Mostly these are solvable, not very big issue, but sometimes these create problems and takes more time to solve. Remember, the device description file is nothing but DD files. For every instrument, we have one DD file, which we have to install in the your PRM, Plant Resource Manager, or in your HART communicator. And mostly these are not very big problems, but sometimes create problems. See, as you know that the foundation field bus initial investment is very high. Let us say if you have a small plant with only 100 instruments, then the foundation field bus is not required there, right? Overkill for small systems. For small plants or limited control loops, FF may be unnecessary. You can go if you have the budget. Otherwise, 4 to 20 milliamp will be fine. These are easy to install, simple to maintain, and cheaper and compared to foundation field bus initial investment. So FF is mainly justified for large process plants. So the foundation field bus provides so many advantages and some problems, right? What are those? Complex design rules, specialized engineering skills required to manage this foundation field bus, higher initial cost, lower communication speed, and difficult troubleshooting. Remember, for process control and monitoring application, the existing communication speed is fine. There is no issue at all. But when you compare with other technologies, the speed is little less. So when you implement this foundation field bus correctly, it provides excellent diagnostics, reduces wiring, and provides distributed control in the field. So the FF is recommended for large process automation systems. Thank you. I will meet you in the next video. If you have any questions, share with us. Thank you for your support.